Let me ask you a question. Have you ever written code that looked like a hot soup of if-else statements? If user is logged out, do this. If user is logged in, do that. If user is banned, well, do something else. And suddenly, the code looks like Netflix password policy, complicated, fragile, and everybody's scared to touch it. Today I'll show you how senior developers completely avoid this mess using state pattern. And by the end of this video, you'll never write a giant if-else chain for behavior ever again. In the next few minutes, you'll learn what the state pattern actually is without textbook nonsense, when you should use it and avoid it, how to implement it cleanly in C#, and how this pattern makes your code easier to extend without touching the existing logic. If you are a developer trying to think like a senior, this one is gold. This video is part of my series Design Patterns Code Like a Senior Dev, where we break down classic design patterns with real-world examples and modern C#. If that sounds useful, trust me, you'll want to check out the rest of the playlist after this. But before we talk about solutions, let's talk about the pain. Imagine you're building a simple media player. This player can be stopped, playing, paused. Now, here's the trap most of us fall into. You create a single class, and inside it, you start writing logic like, if the state is playing and the user clicks pause, do this. If the state is paused and the user clicks play, do that. If the state is stopped and user clicks play, do something else. And before you know it, one class knows everything about every possible state. This works until it doesn't. Adding a new state suddenly feels like defusing a bomb. Here's the big idea behind the state pattern. Instead of checking the state and changing behavior, you let the state object decide the behavior. I repeat, instead of checking the state and changing behavior, you let the state object decide the behavior. Each state becomes its own class. No conditionals, no switch statements, just polymorphism doing the heavy lifting. The object changes its behavior by changing the object that represents its state. This is why seniors love this pattern. It replaces logic with structure. Let me make that painful obvious with a real-world example. Think about traffic lights. A red light behaves differently than a green light. A green light behaves very differently than a yellow light. Do traffic lights constantly check, am I red, am I green, am I yellow? No, each state already knows what it's allowed to do. That's the state pattern. Now, let's implement this in C#, clean and simple. Alright, let's stop talking theory and actually build this. We are going to implement the state pattern using a simple and relatable example, a media player. The player can be stopped, playing, or paused, and the behavior changes based on the state. Let's start from ground up. I'll start by creating an interface called iMediaPlayerState. Alright, so this interface defines everything the state is allowed to do. Notice something important here. Every method receives the media player itself. Why? Because states don't just perform actions. They're also responsible for changing the player's state. This is the key idea behind the state pattern. Now, let's create the media player itself. This is our context, media player. It holds a reference to current state using the interface and not a concrete class. That alone gives us flexibility. In the constructor, I initialize the player in stopped state. Now look at the play, pause, and stop methods. Notice what's missing? Yeah. There are no if-else statements. The media player doesn't care about what state it is in. It simply delegates the behavior to current state. That's the delegation magic. Now let's create the stopped state. This is stopped state. Here, behavior makes sense only for this state. If user press play, we start playback and switch to playing state. If the user press pause or stop, nothing really happens. And look at this. The state itself decides what the next state should be. Let's create the next state, playing state. Now we are in the playing state. If play is pressed again, we do nothing. Pause moves us to the paused state. Stop moves us to the stopped state. Each state knows what actions are valid and what the next state should be. This is clean, this is readable, and this scales well. Let me create the last stage, the paused stage now. Same pattern again, but different behavior. Play resumes the playback, pause does nothing because it's already in the pause state, and then stop would change the state to the stopped state. No conditionals, no shared logic, no fragile code. Let's use this. So to use it, let's create the player. And then let's play. Let's run it to see what happens. Alright, so when we played, it started playing. When we paused, it started pausing. Then if we again play, then it resumes the playback, and stop finally stops the playback. Let me do somewhat of a negative testing now. I play, I pause. Let me play 2 times just to see what happens. Right? I'm expecting this play shouldn't do anything because it shouldn't. Let's run. Right? Started playback, pausing playback, resuming playback, and it says already playing, and then stopping the playback. So all the states are working fine. And now the payoff. From the outside, using this class is dead simple, but internally behavior changes dynamically based on state. Quick reality check. Don't use state pattern if you have just 1 or 2 simple conditions. Patterns are tools, not trophies. Use this when behavior truly changes with state. Let's recap. The state pattern replaces complex conditionals with polymorphism, encapsulates behavior inside state objects. Make your code easier to extend and reason about. This is how experienced developers keep code bases sane as they grow. If this helped you understand the state pattern clearly, hit the like button so YouTube knows that this content is worth sharing. Subscribe if you want to code like a senior dev, not just write the code that works. And definitely check out the rest of the series, Design Patterns Code Like a Senior Dev. Because once you see the patterns this way, you'll never unsee them. See you in the next one.